How are you?
I'm good, thanks you.
Also, you are grade 9, right? Is this your second class?
Yes, yes.
Okay. So also, if there are no people around you, you can turn on your camera. Also, last time you were asking about your homework. So could you do some questions from your assignment? Did you have time to do some problems?
Yes, I did some of them.
How many questions did you solve?
Probably like 20.
So from chapter 3 or chapter 4?
3.
Chapter 3. Okay, good. Okay, awesome. And I hope others will join soon. Now we will continue. As you know, last time we talked about coordinate geometry, right? The equation of a line and slope and the distance between 2 points. These are the things, if you remember, that we did last time. Okay, the length of a line segment, midpoint of a line segment, and we did example 8, we did example 9, right? Also, is that right?
Yes.
Good. Also, is my voice clear?
Yes, yes.
Good. Okay. All right. Eldar, welcome.
Hello, Mr. Kashim.
Guys, why don't you turn on your camera? Are you shy or you are busy or are you having rest or lying down on your bed?
I'm lying from my bed, yeah.
Say again?
Yeah, I'm lying on my bed.
Okay. Okay, Arat is trying to join, but I don't know why he cannot. All right. Also, Eldar, actually, if you don't turn on your camera, it's fine. But actually, if I can see your face, it will be much better because this is a private class. As I told you, this is not a school class. In school class, I know you can just turn off your camera because a lot of students, but here, a small group. Okay. Arat is trying to join. Okay. Okay, I'm just waiting for Arat. He's trying to join us. Okay, guys, I'll see Elder. If you are ready, let's start. Last time, as you remember, actually, we did a few examples about the midpoint of a line segments. I don't know, Arat. Also, how did you join this meeting? Did you just click on the link or you type the meeting code and after that password?
I typed the code.
Hmm. Okay. Okay, let me ask Mr. Darat. Hello. The question is why actually the product must be equal to -1. Okay. Now assume that that is our coordinate system. That one is x-axis. As you see here, we have y-axis. Let's say this is our L1, whose equation is m1 x plus c1. y equals m1, x plus c1. And this is our second equation. Let's say it is y is equal to m2 x plus c2. Okay, and these lines assume that they intersect each other at the angle of 90 degrees. Okay, so from here, again from the definition actually, let's say this angle is alpha, and this angle is, let's say it is beta. Okay, from here, what is m1? M1 equals tangent of alpha, right? Out of this question for you, what is m2?
M2 is equal to tangent of beta.
No, it is tangent of 180 minus beta, because
Oh.
actually we take this angle, the angle between the positive, I mean the x-axis in the positive direction and the line. Okay, not this angle, always this
But
angle.
why?
Huh?
Because if you take the tangent, it will work.
No, if you just take the tangent here, it will be positive, but here this line is falling, right? Its slope is negative here.
Oh, it means if like, but nothing.
Okay,
Okay, I understood.
actually I can just show you from the definition. Actually, we always take this angle, I mean the line and the x-axis in the positive direction. Okay, so otherwise if you just take this angle, it will be positive. If the line is falling, it means its slope is negative. Anyway, let's continue. So we are trying to prove that y m1 equals m2. Now from here, let me just drop a line to the x-axis. Okay, and that is 90 degrees. And let me just call this line h, or not h, let me just say this one is, the height is h. Okay, now from the right angle triangles, what is it, interior angles, as I say here, that triangle is, let's say this one is m, and this point is a, and this point is b, and this point let's say it is h, right? So as you see here, this angle is 90 degrees. So if this angle is alpha, this angle must be, what is it, beta, right? Because alpha plus beta should be equal to 90. Now from the triangle MHB, if this angle is beta, then this angle should be alpha, right? So now from this triangle AHM, AHM, and this triangle AHM, right? What is tangent of alpha? We know that M1, that is slope of the line L1, that is tangent of alpha. What is tangent of alpha? We know that it's just opposite side in the right angle triangle to, what is it?
H and
Adjacent side, right?
AH.
Opposite side is H. So here it is H. Over adjacent,
Capital A,
adjacent
capital A.
side is AH, right? And how about if we find the slope of the second? So the slope of the second here, let me just write here, M2 is equal to tangent of this angle, right? That angle is 180 minus beta, right? And again, 180 minus beta, by just using trigonometric identity, we know that tangent of 180 minus beta is equal to minus tangent of beta. And here, beta is an acute angle, right? Let me just write minus first. Now, what is tangent of beta? I can find tangent of beta either using triangle
H.
MHB or AHM. Again, I will use the triangle AHM. If you use the triangle AHM, this angle is beta, right? So tangent of beta is equal to opposite side, that is AH, over adjacent side, that's equal to H, right? So now if we multiply side by side, on the left-hand side, we have M1 times M2. On the right-hand side, M1 equals this, that is H over A times H, times M2 equals this, substitute here, minus AH over H, right? And this HH, they cancel out each other. Capital AH, they cancel out each other. And here we have, what is it? -1. That is the proof of this. Why actually, if two lines are parallel, the product of their slopes must be equal to -1.
Teacher,
Okay, so
can I ask a
now
question?
if you're given a line segment, or right, we know how to find the coordinates of its midpoint. So if you're actually two lines, we know actually under what condition these two lines are parallel to each other, and also these lines are perpendicular to each other. Okay, now let's just to consolidate this knowledge, practice a few questions, and after that we will talk about something different.
Can I ask
Okay,
a
example
question?
10. Yes, Arat, you want to say something?
Yes, like you said, like tangent of 180 minus beta is equal to minus tangent of beta. Then what is tangent of a minus b, if you want to expand it?
You mean this one, tangent of alpha minus beta?
No, I mean a minus b, any number. How we can expand it?
What do you mean here? Tangent of what? Say
X minus y, any number.
x minus, for
Y.
example, 45.
No, can it be y?
Why?
I want to understand how to expand like inside the tangent.
Arat, let me answer this question a bit later, okay? Because this one I will teach you under the topic of trigonometry. Trigonometry, we will start in chapter 9. Now we are in chapter 4, and we had chapter 5, 6, 7, 8. They are a bit short chapters. And after that, our chapter 9, 10, 11, 12 is all about trigonometry. At the time, actually, I will explain everything in detail. How to expand this? Actually, first we start with this. Here we have cosine of x minus y. Actually, if you will see that if we know how to expand this, using this one, I can expand any, like sine of x minus alpha minus beta, tangent of alpha minus beta, because after all, this tangent of x minus y is equal to sine of x minus y over cosine of x minus y. Okay, but now if I try to explain this, it takes time, but at there, you will see that again, to get actually, I mean, to prove these identities, we will use again coordinate geometry. Okay, because this cosine of y, cosine of x minus y, after giving the definition of cosine, cosine of x minus y is just the difference of two angles, right? Actually, to do this one, we have to first define this in a unit circle. Just in triangle, we cannot actually, how to say, get prove this formula, because this triangle only for acute angles. Usually, we define trigonometric ratios or functions in a unit circle for any angle. So at the time, if this one is angle X, let's say, or angle Y, and this one is, let's say, this angle Y or angle X, this angle between these two rays, it will be X minus Y. To prove this one, actually, we need to find the distance between these 2 points. Again, there we will use the distance formula. And after the once we get the cosine of X minus Y, after that, you will see that just using this fact, I can produce all other identities. That is so beautiful, so nice, but it's not, how to say, I can't do this right now. It belongs to the trigonometry, okay? And maybe we will spend around 1 month for trigonometry. Okay, at that time we will talk about everything in detail. But now let's just focus on our attention on coordinate geometry.
And can I ask one more thing?
Yes.
Will we run extended sinusoidal graphs?
Ask again, say again.
Are we going to learn extended sinusoidal graph?
Are we going to learn extended what?
Sinusoidal.
Sinusoidal? What does it mean?
Yes. Like the graph of sinus or cosine.
How you mean sine functions, sine and cosine functions?
Yes.
Yes, of course. I mean, if we continue this, we will learn everything. Okay, because now I'm teaching you grade 9 materials, and hopefully we will finish this in 3 months, maybe maximum 4 months. And after that, I will start with you new stage. This is the stage one of this class. And if we continue after 4 months, then we will start new stage. It will be around 6 months. Of course, it takes time. At that time, we will learn, what is it? We will learn about polynomials, non-standard equations, and the factor theorem, trigonometry, and the binomial expansions. Okay, and also derivatives, integral. We will see. But right now in the stage one, we have to finish all of these topics. Okay, Arat?
Okay. And do we have calculus in stage 2?
In stage two, of course.
We have calculus.
In stage two, if we continue, we will see.
Yes.
I mean, because here, this one is level 3. You know, in secondary school is divided into 2 levels, right? Secondary 1, secondary 2, or some countries they call this secondary school and the high school. Now, what we are learning here is the last stage of secondary school math. Okay, after we finish this, then we will start high school math. High school math is, that is 10, 11 or 10, 11, 12. That is 2-year course. Okay, and after that, after we cover those topics, then what is it? You are ready for university. Then university topics will start. Okay.
Okay.
All right. Example 10. The vertices of triangle ABC are, okay, it's given. Find the value of K if ABC is 90 degrees. Okay. Maybe in different ways we can actually solve this. But here our topic is coordinate geometry. So we have to consider everything in the context of coordinate geometry. Because after all, you know, we have a lot of different skills. Sometimes we can use trigonometry to solve some questions. We can use some finance, right, to solve financial questions and the coordinate geometry questions. But here we are trying to approach everything from the point of coordinate geometry. Okay, here we are talking about the verse of ABC. It says that angle ABC is 90 degrees. So that means that our triangle is something like this, right? So this one is A, this one is B, and this one is C. And coordinates are given. A, it is 0, -5, C, 10, K, and B, it is -2, 1. B, -2, 1. What is the question? It says that if triangle ABC, what? Angle B is 90. Why did I write like this? Angle ABC. So this one is B. It is -2, 1. And this one is A. That is 0, -5. Okay, angle ABC is 90 degrees, so we have to find the value of K. So how do you find this? Since ABC, right, it is 90 degrees, that means that the line that passes through AB and the line that passes through BC, they are perpendicular to each other. That means that, let's say the gradient of this line, it is M1, gradient of this line or slope of this line, that is M2. So here we know that M1 times M2 should be equal to -1. Now, how do you find this M1? I mean, that's the gradient of the line that is passing through B and C. That's equal to M1 is K minus 1, K minus 1 over 10 minus -2, which is equal to 12. Over, how about the gradient M2, the gradient of AB, -5 minus 1, that is -6, over 0 minus -2, that's equal to 2. From here, K minus 1 equals -3 times 12, -36. And what is K? K equals -35. Is that correct?
I think yes.
Okay. I mean, if you're interested, you can just plot these points. Okay, then you can see. You know how to plot these points?
In the like calculator graph?
A calculator or Graphmatica. Have you ever used Graphmatica?
I use Photomath. Because it's just easy, you just plot everything. Just
Okay, all right. I usually use Graphmatica. It's very, the size is small. You can download this from Google, and you can just draw this so quickly. Anyway, we'll talk about this later. Another question. Also, can you read the problem?
The point P is equidistant from R -2, 4 and S 6 -4, and its x-coordinate is twice its y-coordinate. Find the coordinates of P.
Okay. A point is equidistant. Equidistant means, what happened? Equidistant means, what is it? Having the same distance, right? So equidistant from R and S. So that means that if this one is R, let's say, and this one is, let's say it is S, so maybe P is somewhere here. So this one is P, and this distance are equal, right? This distance are equal. Coordinates of R, that is -2, 4, and this S, it is 6 minus 4. And how about P? We don't know. And its x coordinate is twice its y coordinate. What does it mean? It means that if its x coordinate is 2a, its y coordinate should be a, right? Because it says that x coordinate is twice its y coordinate. If y coordinate is a, its x coordinate should be 2a. Find the coordinates of P, right? How do you find this? Find the coordinates of P. Some people, they just draw this like this. Okay, this one is R and this one is S, and this should be P. But here we don't know that these three points are lying on the straight line or not. That's why you should not draw like this. It can be anything, right? Yes.
Is P 90-degree angle? Because
No.
it's equidistant.
No.
What does mean
equidistant means this P is equidistant means from the point P, if you walk to point R or if you walk to point S, you actually, the distances are the same. Equidistant means having the same distance.
It means that x coordinate is the same as midpoint, yes?
No, it's
No?
not like this. Because here, you know,
I mean,
this S, it can be anything. It's like this. For example, if you're talking about a circle arc, let's say this point is P. Okay, that means that this point is somewhere on the circle R, and this S is somewhere on the circle here also S. Equidistant means these two distances are same.
teacher, no, I mean, it meant the x coordinate of P is not the same as the midpoint of R and S. It means it cannot be like.
No, it cannot.
It's not 2, the midpoint.
No. Yeah, because as I told you here, the location, it can be anything here. So we cannot say that, you know. Here,
No,
the
I
only
mean,
thing we know here is these distances are equal. So I can just write here PR is equal to PS. Equidistant means this. Now we know the distance formula. That means that this PR squared is equal to PS squared because both numbers are positive. Now from here, what is PR? We know how to find the distance, right? It is 2a minus 2. So that is 2a plus 2 squared. And here we have a minus 4. Here we have a minus 4 squared. On the right hand side, PS squared. That is 2a minus 6 squared, 2a minus 6 squared. And here we have a minus 4. That is a plus 4 squared. It means
why
this
did
because.
you square it?
Yes, Ara, say again.
Why did you square it?
Because I don't want to have a root here. Even if I have a root, something like this, let's say here we have x squared equals y squared. That is, these two expressions are equivalent to each other. Right?
You want to like get rid of it?
Yeah, even if I put square, right? If I put the square root here, in my next step, I will remove it. I just do that step mentally. Okay?
Okay.
Good. Because you should do this, actually, you should write this step, and after that, we should write this step. But here, I assume that you understand this step. That's why I just removed. And now we have to solve this equation. And also,
No,
we will do simplification mentally. Here we have 4a squared plus a squared. So here we have 5a squared. And here we have middle term is 2a times 2, 4a times 2, 8a. And here we have minus 8a, right? So that's equal to 0.
Plus 4a.
Right? And here plus, here we have 4 plus 16, that's equal to 20. On the right hand side, 4a squared plus a squared, that is 5a squared. And here we have 2 times 6, 12, 12 times 2. Let me just write here, minus 24a. And here we have 4a plus 8a. And constants is 36 plus 16, that's equal to 52. So this 5a's squared, they're gone. So minus 24 plus 8 minus 16, take to the left-hand side. Here we have 16a equals, take 28 to the right-hand side. It is 32, right? What is a here? A equals 2. What is the question? Find the coordinates of P. So dot, 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 coordinates of P are 4 and 2. Okay?
Okay.
Good. Another question. How many questions we have? Oh my gosh, we have a lot. Okay, no problem. We should go a bit faster then. Arat, can you read the question?
The equation x plus 3y equals 1 intersect the curve 5y equals 20 minus 3x minus x squared at point P and Q. Calculate the length of PQ.
Okay, we have already done this kind of question, right? So we are talking about the curve. That is the equation of a curve. So if you want to make sure that what kind of curve is it, immediately using graph method, we can draw its graph. We assume that is a kind of curve, something like this. Okay, so, and that is our line. So that's our line. And it is intersecting the curve at two different points. Number one is P, and this one is Q, right? And that is our, the graph of this equation, and the curve is this. So calculate the length of PQ. So first, to calculate the length of PQ, we have to find the coordinates of P and Q, right? And also, as you know, that to find this, since these are the common points, we have to solve these two equations together. And from the first one, I can express x in terms of y, that is 1 minus 3y. Now substitute this into this equation. So here we have 5y is equal to 20 minus 3 times x. What is x? It is 1 minus 3y minus x squared. 1 minus 3y squared. So the rest is just simple algebra. We have to clear all the brackets, expand them, right? And take everything to the left-hand side and just solve the quadratic equation. Because as you see here, we are going to have a quadratic equation here. So 5y is equal to 20 minus 3 plus 9y. And here, if you expand this, here we have 1 squared, that is minus 1. Here we have minus 6y, but this minus it is plus 6y, and plus 9y squared, but this minus it is minus 9y squared.
Can I ask a question?
Yes.
Teacher, I know like we substituted, but can you prove that it works?
Which one works?
No, I meant like putting like the thing, I mean like substituting x and like putting 1 minus 3y. Like then when you draw like the parabola, like you mean the x intersects are P and Q, but how?
Okay. Here, actually, that x and y, these are not x and y. These are some constant
Point.
numbers. If I draw here y and x, okay? So this one is, let's say, some kind of, actually this one is, okay, here we have this kind of parabola. Okay, and this one is our line. All right, so assume that they intersect each other at P, and here they intersect each other at Q. Okay, what is the meaning of this substitution? Means that Arat, here, let's say the coordinates of P. This coordinates of P, let me just write here, coordinates of P, let's say it is A and B. Okay, and the coordinates of Q, we know its coordinates, right? Let's say it is C and D. Okay, so that means that these are fixed numbers, constants, they are not variables. Since this point belongs to the parabola, at the same time it belongs to the line, right? That means that if I substitute the coordinates of P into these equations, it must satisfy these equations. That means if you substitute this here we have A plus 3B will be equal to, it's not an equation now anymore, it's an identity, right? Because here A is not unknown, B is not unknown, these are numbers. And if you substitute into the second equation, we will have 5B will be identically equal to 20 minus 3A minus A squared. Okay, so now what are these A and B? How do you solve this? Now we have algebraic equation. Okay, using these facts, actually using this geometry, now we got algebraic equation. Now from here, we are solving a system of equations. One is linear, another one is non-linear. Right? How do you solve this equation? To solve this one, we have to, because here we have AB that satisfies the first equation, AB that satisfies the second equation. Since it is so, from the first equation, I have to express A in terms of B and substitute here. Right? It's the same thing what I'm doing here. This is the first step, second step, and third step. Do you understand? Because there's a connection between geometry and the algebra here. That is how we are manipulating these things. Hello, Arat? Anything not clear?
Can you hear me?
Yes.
So I don't speak loud, and because my microphone is like, the sound is not coming clear.
Okay. And do you have any question, Arat?
And no, at the middle I understood.
Okay. So what's going on here? Actually here, this X and Y, these are not variables, because even if we just label A and B, nothing changed. That's why we just keep it as X and Y. So now if you simplify this, take negative 9y squared to the left-hand side. Here we have 9y squared. And here we have 9y plus 6y, it is 15y. Take to the left-hand side, 5y minus 15y, that is minus 10y. 20 minus 3, 17, 17 minus 1, 16. Take to the left-hand side, minus 16 is equal to 0.
Teacher, you forgot it, the 9.
What 9?
Oh, sorry. I thought the 9 doesn't belong to.
Okay, so here, now we try to solve this by factorization. Can we solve this by factorization? For example, let's say this 3y is 3y. I don't know if it works or not. And this one is, let's say, 4.
Maman صدا در نیار.
It's 8, 2. It is 24. 6 doesn't work. How about 9 and how about like this? It is 9y and y. This one is 8 and 8 and 2. It works, right? So 9y times y is 9y squared. Here we have 18, it's minus, so this should be minus. Negative 2 times 8, negative 16. If you cross multiply, negative 18y plus 8y is equal to 10y. So we can factorize it as 9y plus 8 times y minus 2 is equal to 0. So from here, y equals minus 8 over 9. Let's say this y sub 1. And y sub 2 is equal to 2. Now, if we substitute this into this equation, we will get x1. x1 will be 1 plus 3 times 8 over 9. That's equal to this 3. 3 is 11 over 3. And if you substitute y2, here we have 1 minus 3 times 2. That's equal to negative 5. So now, dot, then coordinates of P should be 11 over 3 and minus 8 over 9. And coordinates of Q should be negative 5 and 2. Okay. Now, let's just see this quickly. What is this? Here we have 5y minus equals 20 minus 3x minus x squared, and x plus 3y is equal to 1.
But how to plot it in the calculator?
Say again?
How to plot it in the calculator?
Okay, Arat, can you see my screen now?
Yes.
Graphmatic. Okay, let's do all this, then I'll answer your question. The first one is 5y is equal to 20 minus 3x minus x squared, right? And that's our graph. Second one is x plus 3y is equal to 1. Okay, so these are our graphs. They intersect at 2 points. This Graphmatic, you can have a look in the Google. It is so easy to use. Now here we have intersection, and evaluate, find intersection in tools. Now if you just click on find intersection, it gives us coordinates. Calculate, as you see here, at minus 5, 2, that's the first intersection point here, and the second one is 3.66 and minus 0.88. That's another fraction. Actually, we have already calculated. What is it? It is 11 over 3. It is 3 point something minus 8.9. It is 0 minus 0 point something. Okay. You can use just that Graphmatica to check your answer. Okay, just to have the visual what is the solution of this question. Okay, let's try to finish these questions, guys. Here we are a bit slow today. We have 2 questions, and after that you will have discussion. Okay, maybe next time. So exercise 4.1 Q question 10. Actually, these are from your assignments. Given the points P, Q, and R, and find the possible values of K if PQ equals 2 times QR. Okay. It's also a similar question. We are given 3 points. We don't know that they are on the same straight line. So what we know here is PQ equals 2 times QR. So this one is PQ, maybe QR is something like this. So this one is P, this one is Q, and this one is R. What we know here is PQ equals 2 times QR. From here, what is PQ? PQ equals, again, we have to use the distance formula, right? PQ equals K minus 1 squared. That is K minus 1 squared plus 3 minus 1 squared. That is 4. And how about QR? QR is equal to QR square root of 6 minus 1. It is 5. 5 squared plus 1 minus 2 is negative 1. Negative 1 squared is 1 squared, which is equal to 26. So from here, it says that PQ equals 2 times QR. That is square root of, let me simplify this, K squared minus 2K plus 1 plus 4, that is plus 5, is equal to 2 times QR. What is QR? Square root of 26. And we know that to solve this equation, we have to square both sides. Then here we have K squared minus 2K plus 5 should be equal to 4 times 26. Or K squared minus 2K is equal to, what is 4 times 26? That's equal to 112, right? And to take 5 to the right hand side, 4. Anyway, let's just take to the left hand side. It is 5 minus.
Teacher, can I ask something?
Yes.
Oh no, sir, it's plus.
Is it? So here, if I just take 4 to the right hand side, here we have plus 1, Take 4 to the right hand side. 104 minus 4, that's equal to 100. Because I'm just going to solve this in, by completing the square method. What is k squared minus 2k plus 1? We know that that's equal to k minus 1 squared. And on the right hand side, we have 10 squared. And we know that if x squared is equal to, let's say, 4, that means that x equals plus minus 2, because we can factorize it as x minus 2 times x plus 2. The same thing for this. That means that k minus 1 equals 10, or k minus 1 is equal to negative 10. From here, k equals 9, or k equals
Teacher, k equals 11.
11. K equals 11, and here k equals negative 9. So we have two possible answers. The possible answers of k are, what is it? Negative 9 and 11. That means that we have two possible points which satisfy the given condition in the question. Okay, maybe one is somewhere here. What is, we are talking about p, right? Maybe it is somewhere the other sides, because minus 9 and 11 very opposite sides, right? Okay. Well, that's our last question. And let me skip this because it's a similar question to the previous questions. You will do it yourself. And the equation of a straight line, I will skip this. I will finish with this question. Okay. I think we cannot finish all. That's the last question, I think. Or we have more questions. Guys, after this, let's just solve one of them or two of them. Okay. And we will continue from where we stop. Equation of a straight line. Let's see here in the diagram, we are talking about this picture, and it's a quadrilateral ABCD, and in which A is on the y-axis. As you see here, A is on the y-axis. That means that it is x coordinate is equal to 0. And D is on the x-axis. That means that it is, what is it? Y coordinate is equal to 0. C is the point 16, 11, and the equation of AB. Equation of AB is this, y equals 2x plus 4. If AD and BC are perpendicular to AB, what does it mean? It means that AD and BC are parallel to each other, right? Since this AD and BC, they are perpendicular to the line AB, that means that these two lines are parallel to each other. Okay, fine. Number one, coordinates of A and D. Let's try to start from the first one. I think I can just open a small window here because we need a bit more space to solve this question. So let's start with part A. So since A is on the y-axis, we know that its coordinate should be something like this, 0, y sub 0. And how about D? D is on the x-axis. Its coordinate should be something like this, x sub 0, and here we have 0. Y coordinate is equal to 0 because it is on the x-axis. What we know here is, we know the equation of AB, right? We know the equation of AB. So equation of AB is y is equal to 2x plus 4. And from here, immediately I can just write here that gradient of AB is equal to 2, because here mx plus 4, right, in gradient form. So its gradient is equal to 2. So now from here, since AB is, the equation is given, right, and this A belongs to the line AB, if we substitute this into the equation, it must satisfy this equation. So from here, y sub 0 should be equal to 2 times 0 plus 4, which is equal to 4. So dot, 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 coordinates of A are 0 and 4. And how about AD? From this equation, we know that the gradient of AB times gradient of AD should be equal to -1, because they are perpendicular to each other, right? So if we continue, what is the gradient of AB? It's equal to 2.
-1/2.
So from here, that's equal to 2 times gradient of AD. What is the AD? And then we know the coordinates of D, right? So that is x, y0 minus 0. That is y sub 0 minus 0 over 0 minus x sub 0. That's equal to -1. We know the value of y sub 0. That's equal to 4. 2 times 4 is 8. So 8 over minus x sub 0 is equal to -1. From here, what is x sub 0? That's equal to 8. So here, dot, 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 the coordinates of D are 8 and 0. Okay. And how about part B? I mean, question B. Let me change the marker color or pen color. It's B. It says find the equation of BC. And how do you find the equation of BC? It is passing through C, right? So we know that if we know the specific point P, and if we know the gradient of M, then we can write the equation of this line. What is it? That is y minus y1 over x minus x1 is equal to M. Using this fact, here it's passing through C. And what is the gradient of BC? And we know that gradient of BC is equal to gradient of AD because they are parallel to each other, right? So that's equal to, what is the gradient of AD? Gradient of AD is equal to -1/2. That's equal to -1/2. So since it is passing through the C, the equation of BC should be y minus y1, that's equal to 11, over x minus x1, that's equal to 16, and its gradient is equal to -1/2. Or y equals -1/2x plus 8 plus 11, which is equal to -1/2x plus 19. Okay?
Okay. Just where did
Also,
you?
Arat Eldar, I had to stop here because after you, I have another class. They will have to wait otherwise. Here we have C and D left, and also example 14. And okay, these two questions. If you can try to solve this, and you can send it to me. If you cannot, we will have discussion on this too. Okay, and after that, we have two more topics from here. It's about area of rectilinear figures and the circle. Then hopefully I'll try to finish this chapter next in our next meeting. Okay, guys.
Okay.
Thank you very much. And I'm ending this meeting. Okay, I will see you on Friday.
Bye.
Bye
Bye.
bye. Also, bye bye, Arats.